So Hiba, Jashan, and myself will be talking about ALMA. So what is the ALMA? So ALMA actually it's an array, so it means an arrangement of antennas, and the antennas usually have a 12-meter diameter, and there's 12 that have a 7-meter diameter. It's located in Chile in the Shagnan Tour Plateau, and it actually means a place of departure in the Atacama Desert in Chile. So how did it start? Well, even before ALMA started, there were three different proposals, one from the USA, one from the European Observatory, Southern Observatory, and the other one from Japan. So each of these organizations, they wanted their own projects. For example, USA wanted 40 antennas at 8-meter diameter. The European Southern Observatory and Japan, they wanted 50 antennas each. But the European Southern Observatory, they wanted 16-meter diameter, and Japan wanted 10-meter diameter. So at the end, each project was going to be really expensive, and then they decided to make it a joint project just to reduce costs. And as you can see here, it's really nice because you can see the Milky Way pretty clearly. So the location, as I mentioned, is the Atacama Desert. So they're on right here. And it's known because it's flat, so that's why it's a perfect location. It's one of the driest places, and that is perfect because water tends to absorb the wavelengths that they're looking for. And it's 5 meters above the sea level. And it's really far from the other towns, of about 40 kilometers, and that's why there's less light pollution. And there's about 300 clear nights a year, which is much better than Vancouver. And it's also perfect as you can actually see the center of the Milky Way. And as you can see in figure 4, it's an arid place, so really dry, and less water means that the water won't absorb the frequency, the wavelengths that we need. And something interesting about the location is that it's really similar to Mars. So they took the Zoe rover, and as you can see here, it digs through the surface and it looks for microorganisms.
Hello everyone, my name is Hiba and I will be talking about how ALMA was built and how and why is ALMA used and how is it used. So let's start with how ALMA is built. As we all know by now, building ALMA, it's very expensive. It costs roughly $1.4 billion, which it's very expensive for any university or any country to fund it. That's why it's a full international project. So it combines, as we all know by now as well, United States, Europe, and Japan. And after we had Taiwan and Canada, they also joined the project. So if we take a close look at the ALMA, we find that there are 4 different types of antennas. So United States, they made 25 antennas, which are like only 12-meter antennas, and Europe built also 25 antenna, which was 12 meters antenna. Japan has built 16 antennas. It built 12-meter antennas and 7-meter antennas. So in 2009, the first antenna was transported to the observatory in Chile at 5,000 meters above the sea. The first science observation was made in 2011, although they only had a quarter of the antennas in the operations. On the 13th of March 2013, this observation was officially opened in Chile. Okay, so now I will be talking about how ALMA works, like how does it work. Before I start with the steps of how it works, I would like to make it clear that we all know that there are 66 antennas and they all located in one location and they all work together. They're all like synchronized together. They receive information together and they send informations together. To make it more, to have a more accurate results and like accurate images and like everything to be perfect this way. So let me start with the steps. So number 1, the signals is collected by the antennas. The moment the signals reaches each antenna, it must be measured with an accuracy similar to the diameter of a human hair. It's like hundreds of millimeters. And then those signals, it goes to a place called the front end. The front end is where the signals is measured by a sensitive receiver. It's cooled down to 269 degrees. The signals are then digitalized by the back end, where it converts from analog to dialogue. And then those digital signals, when after they're converted, they are transmitted up to 16 kilometers kilometers of optical fiber, to the array operational site, which is the AOS. So over there they have a correlators. It's an area where it collects and combines all the signals from the antennas and all the data. After combining all the data and collecting everything, they send it to the OSF. The OSF, it's the Operation Support Facility. It's the Central Archive in San Diego. After they receive all the data from there, and then they start sending the data to the ALMA regional. Okay, so why is ALMA used? What is it used for? Why all of this money spent on it? So ALMA is used to study the planet system, the planetary system. So, and also uses the millimeter and submillimeter wavelength. The reason they use those wavelengths is because it will because which makes the planet easier to observe and also can provide higher resolving power than current optical and infrared telescope. It can show a better image of the planet and what's going on over there. Also it can help gather data about worlds inside of our solar system. So it has a lot of benefits. This is why it's very important, and they spend all this money on it. So the figure number eight, it shows that this was the first higher frequency picture that we've been taken from ALMA, which is very interesting, and it shows the wavelength and like how it happens, which is very interesting. Honestly, I find it, and yeah, this is what they use ALMA for. Alright, so the picture that's on the screen, it's pictures that has been taken from ALMA, using ALMA. So the first picture, which is figure number 9, it's the first picture was taken by the astronomers when they captured the best image ever of planet formation around the infant star as part of the testing and verification process for the ALMA. So as a new high resolution capabilities, and it actually passed the testing, and it was verified as it has a very high resolution. And then after passing all the verification, all the testing and everything, and then figure number 10, it's the ALMA's first taken picture. So this is the picture over here. I think it's beautiful. It's really nice. And yep, so this was my part. Thank you so much for listening, and I hope you enjoyed it. If you have any questions, please do not hesitate to let us know. Thank you.
To recap, this project was created by observatories in the US, Europe, and Japan. After scouting for locations, northern Chile was chosen due to reasons such as sea level and low light pollution. The ALMA project is so interesting and fun to learn about, considering facts such as the observatory can view a golf ball 9 miles away. It took thousands of scientists and engineers from around the world more than 10 years to complete. The observatory cost well over $1 billion to complete. Fortunately, it was split by the 3 main countries involved. Space exploration from Earth is a safe and effective way to understand and learn about the unexplored aspects of space. The ALMA project has opened a new window on the way we observe the Milky Way, and it has the power to expand our knowledge regarding the universe.